Okay, we're going to look at another example of using Dijkstras algorithm. And in this case, we're going to try and find the shortest route from A all the way over to J. Okay, so this is a slightly more complicated example where just doing it by inspection might not be the best idea. So the first thing we do is that we label our starting vertex A with 0, because obviously we're not going to move anywhere to actually get to A. We are already at A. Okay, so first of all I label it 0 and box it off. Now I look at each of the edges coming out of A that I have not travelled along yet. So to get to B is 3, and to get to C is 4. Okay, so I look at 3 and 4 and I go, right, which one is the smallest? So I'm going to look at 3, the smallest unboxed number. So as soon as I am starting to consider it, I box it off. From B I can get to E in 8, so 3 and 8 is 11. And to get from B to D, 3 and 5 is 8. Okay, so I've now considered all of the routes coming out of B. Okay, so there are no more to think about. So now I've got 11, 8 and 4. I pick the smallest one, and that is 4. So I box it off because I'm considering it. So I look at all the routes coming out of C that I haven't already travelled along. C to D, 4 and 2 is 6, which is better than 8. So I cross out 8 and write 6, okay, because I found a better route to get to D. The examiner wants to see your crossing out. Okay, all you need to do is just put one line through it. Okay, you don't scribble it out so the examiner can't see what the number is behind. Just one line through it. Also coming out of C, I can get to F. 4 and 7 is 11. Okay, so now I'm looking at 11, 6 and 11. So I'm going to consider 6. So I box it off because I'm considering it. 6 and 7 is 13, which isn't better than 11. So I don't cross out 11 and write 13. Okay, 13 is not better. So I ignore it. 6 and 6 is 12. So I can get to G in 12. 6 and 4 is 10, which is better than 11. So I can cross out the 11 here and write 10. I now have the situation where I've got 11, 12 and 10. I'm going to pick the least value of these. That's 10. So I box it off. And I look at the route that I haven't travelled along that takes me out of F, which is 6. 10 and 6 is 16. Okay, that was the only route coming out of F that I haven't travelled along. So now I'm looking at 11, 12 and 16. 11 is the next least, so I box it off. 11 and 5 is 16 to get to H. The next one to consider is 12, so I box it off. Now, 12 and 4 is 16. Okay, I've already got 16 there, so I don't need to do anything. 12 and 3 is 15, which is better than 16. So I can cross out 16 and write 15. Okay, and that is all the routes coming out of G that I haven't already travelled along. Brilliant. So now I've got 15 and 16. I'm going to box 15. 15 and 4 is 19. Okay. Box 16 because that's the next one to consider. 16 and 4 is 20, which isn't better than 19. And finally, just box the final number, 19. So the shortest route from A to J has a value of 19, but we also need to actually write down the route itself. So we work backwards. So we end up at J, okay? 19 take away 4 is not 16. 19 take away 4 is 15, so I travelled from I to J. 15 take away 6 is not 10. 15 take away 3 is 12, so I travelled G-I-J. Okay, from 12. 12 take away 6 is 6, so I went D-G-I-J. 6 take away 5 is not 3, but 6 take away 2 is 4, so I went C-D-G-I-J. And 4 take away 4 is 0, so that gets me back to A. So the route that I travel along, the shortest route, is A-C-D-G-I-J, and it has a value of 19. Now, as already mentioned, okay, not in this video but the previous video, the good thing about Dijkstras is that it tells me the shortest distance from A to any of the other points. Okay, it doesn't tell me the shortest distance from I to E, but it does tell me the shortest distance from A to E, and A to B, and A to D, and A to C, and so on. Okay, so bear that in mind if an exam question comes up and asks you now, what is the shortest distance from A to G? Well, that would be 12, the number you have boxed above G. Okay?